All right. So last time I said that we would talk about this paper, and we're going to talk about it just a little bit. Did you guys get out those sheets that Kara gave you? Make sure your names are on them. Collect them in a little bit here. That's right. Yeah. That's just 2 pages. I don't need the blank stuff. What did you guys, what were your impressions, your thoughts of this paper? What did you, what's that? Science-y. It was science-y. Yeah.
I'm like, yeah, I use my body therapy.
So you questioned their methods.
Yeah.
Yeah.
Previous.
Sure. This is actually really common in the literature. There's a lot of data sets that get collected out there, particularly in medical environments and healthcare environments. And there's not always researchers there to analyze the data, but or there are researchers that will take that data and do the analysis on that data, but it was not the people who initially collected it were collecting the data, but not intending to necessarily do the analysis themselves. So this is a fairly common type of study, and it is dependent upon the rigor with which the initial collection, the original entity collecting that information. The only way to do a paper like this would be to survey, right? You couldn't. You're not going to be able. I mean, you can't just magically observe that number. And certainly, you couldn't ask everybody out there. So you're going to have to take a subset of the population and extrapolate. That's what polling. What else? Yeah. How would you go about getting that background information? It's a great question. Yeah, right. So uh, if you were to go into the methods and or whatever in the paper, somewhere in the paper, they talk about that survey. I am certain that survey is referenced itself, and so there's this hierarchy of papers that you can follow down and actually get to that base information. And the reason they wouldn't have gone into that data, presumably, is because it what like the specifics of how it was collected is because that data has already been reported somewhere, and they are talking about the analysis that they're making on the data, and not as much about the actual collection. Whereas that's going to be referenced somewhere else in the. But that's a good question. Yeah. Oh, I wonder what that actually means. So, for example, sometimes in a methods, they'll reference some technique. And they'll say they did such and such technique, and there'll just be a number next to it, and you go down and it's like at number 5, and number 5 is some paper in the literature. And you got to go to that paper, and maybe that paper is referencing something. You have to go through this chain of papers to get to the actual information. What else? Any other thoughts? Yeah. Yeah, absolutely. Yeah. No, I mean, the first step in understanding is just what's the scope of usage? How big, how widely used are these methods? And that's probably one of the reasons this paper has itself been so highly cited. You saw that it was cited 41 times. So for a paper that was published in 2009, that's a fair number of literature. There's a lot of papers out there that go unnoticed, cited. That means 40 other studies, which are going to branch out and be cited themselves, are channeling back through this paper. And who knows how many times those other papers got cited, so on and so forth, in the past. So there could be thousands of papers that, if you followed a paper trail of references through them, would lead you back to this paper. Getting at how seminal it was. Anything else? So I want to use some of the, beyond just kind of giving us a sense of like how many people actually do yoga, how many people actually do Tai Chi, that kind of thing. Besides getting a sense of that, and thinking about where you as a person fit in to that, and your experience, and thinking about the people you know, and does that match up with what they find. I want to use the paper as a way to just introduce looking at scientific, right? Just looking at scientific data a little bit. So I'm gonna go through some of the tables in the paper with you guys. And this is not graded. There's no stress. This is just me asking some questions and seeing what if you guys get it. So, question: is yoga or Tai Chi more prevalent? So that's the question. Say I'm a researcher and I want to know this question. Maybe I asked you. I said, is yoga or Tai Chi a more popular thing in the U.S.? I don't know. You don't know. So you go and you find this paper, right? You go and find this paper, and here's the table. Now look at this table. How are you going to answer that? Yoga. This is straightforward. So 5% of the population does yoga, and a little over Tai Chi. So 1 in 100 people do Tai Chi, 1 in 20 people do yoga. Yeah? I don't know, man. There's a lot of people. Maybe, yeah, your environment is selected. There's got to be socio components to that. And that's sort of what the paper's teasing out anyway. So we're going to get to that. So this is like super straightforward, basic fact gathering. Like this is a question that is directly addressed in the right? So question: what percentage of yoga practitioners are men? Are men? Huh. Wow. Okay. What do we have here? Yoga. So, well, here's the sample. So this is sample size. They must have sampled 31,000 people, extrapolated that to this estimated population, and of those 31,000 people, 5,000 were mind-body therapy, so some sort of mind-body yoga. This number. So then here is the breakdown. There's these relaxation techniques, and we'll go back. these relaxation, any of these things are all sort of rolled up into. Here's yoga and here's Tai Chi. They're separate. So I'm interested in what percentage of yoga practice. Yoga, all these numbers. We're looking for men. So what do we have? Age, nope. Sex, that's us. Female, there's no male. Super straightforward, simple subtraction. Okay, am I insulting your intelligence here? Yes. Sorry. So let's go on. So this is data that's not explicitly shown in the table, but it is implicit. Without a doubt, you can get the number 24 out of it. It's not explicitly written, but if you want to know how many men, it is implicit. You guys follow me here? Okay, so I'm just showing different ways of interrogating data. So, all right, here let's go another level up. Which is a greater predictor of yoga practice? Age or education? Age or education? Which is a greater predictor of yoga practice? Age or, where is it? Education. So we're looking at yoga, this column. Age is this, and education is down. So, what are all these numbers? What are these numbers? Percentage. So if they're percentages, that means they should add up to 100, right? So 20 plus 26 plus 7 is 53. 76 is 96 plus 4 is. So which is a better predictor of yoga? Age, guys say. Education, some people are saying. Why? Yeah. So this means if I had some information about a person and I wanted to predict whether they were going to be, whether they did yoga or not, would I rather know their age or their level of educational attainment? Okay, and why would you say that? Okay, so you're saying that these numbers are close to one another, and that this number is low, so the people, whereas variation. Is that what you're claiming? Is anybody who agrees with that analysis? Who disagrees with that analysis? Okay, you think age is a better predictor. Okay, why? Yeah, okay. I like that you're skeptical. Yeah. Okay. Does anyone want to respond to that? There's definitely some sophistication here. That this is not a straightforward answer to this question. So let's hash it out. Yeah. Yeah, so we need multivariable overlap, right? We're beginning to ask questions that you're beginning to ask questions that are not completely explicit in the data. Uh, there's another problem here. There's another problem. Does anybody see it? Yeah, what do you think? That's just right. Not necessarily, because clearly this is a pretty good category, because above 65 was roughly a fifth of the population. Yeah, yeah, they weren't. They were talking to adults, not. They could have teased it out a little bit. Sure, they could have put more categories in here, like 2 year degree versus 4 year degree. But that some college, a year of college, 4 years of college, 2 years of college, went for a year, dropped out, whatever. You went to college a little bit, so that's that whole group. And again, that's a reasonable category because that represents 25% of that, 28%. That's not a grossly distorted. Sort of giving you hints here. When I keep talking about these categories, you guys are dissecting the categories, and I'm glad you're looking at it. When we're talking about that, we were talking about yoga, right? But have I been pointing to the yoga column? No, I've been pointing to the general population. Huh? Okay. So what? Why? What's significant about that? Explain.
16 people. High school.
You're talking about this. Which? Yeah. Yeah. Those numbers are a little off, but she's heading in the right direction. Nobody's nailed it yet. Nobody's really nailed what I'm trying to get at yet. But she's heading in the right direction in that she's comparing these columns. She's using this data to help her interpret that data. So, Nikki, what? Yeah. So, how about this one? Let's look at these people. 21% of the general population is between 50 and 60. 21, no, I'm sorry, 20%, did I do that right? Yeah. 20% of mind body therapy people do yoga. Those are pretty much the same number, right? So that means that being 50 to 64 years old does not distinguish you as someone who really likes to do yoga compared to the other people, the other category, right? So let's look at here. Um, these numbers are pretty comparative to these numbers, all right? Meaning that by age, whether you do yoga, it's pretty representative of how many people there are of that age. So you're not more necessarily more likely to do yoga if you are 40 to 49 than if you are 50 to 64 because those numbers are pretty much the same, whether you do yoga or whether you're part of. the general population. You guys following me? All right. Whereas here, these numbers 16, 30, 28, 24, these numbers are much more off from the general population. So your educational attainment has a much bigger effect in skewing you from just an average, any random person out there than your age does in terms of doing. You guys following that? So I'll show another example of this that's a little more clear, but this is this. So if you're looking at this and not comparing it to the general population, you would say educational attainment is a better predictor, all right? Because these numbers are all pretty much the same, except 65-year-old is kind of low, and you expect that. But down here, the level of educational attainment, if I were to ask someone if they have a graduate degree, well, 1 in 2 people do, with a graduate degree, do yoga, whereas 1 in, what is that, 40 people like that, do 1 in 35 people do yoga if they don't have a high school. So if I were to predict, if I met someone and they said, "Oh, my name is Dr. Klepak," or what, I would guess with a fairly high, likelihood of being correct that, oh, they probably do yoga. There's like a even chance they do yoga. Like half the time, I guess, they will do yoga. Whereas if they had never been to high school, I would guess probably that they haven't done yoga because I'd have to meet 34 people before I met one statistically that had done yoga with that same level. All right. So that's a high predictor. Whereas here, it's not. It's really kind of, these numbers are fairly tightly. If you meet an old person, probably not. But anyone who's not feeble is roughly the same likelihood of doing yoga. It gets complicated though because you cannot say this is our, you don't want sample bias to throw you off, right? Maybe we only interviewed 4 old people, 4% of the people, right? So you're comparing. You have to compare it to the sample size. So let's get another example and see. Maybe is marital status a strong predictor of mind-body therapy? What do you guys think? Marital down here and mind-body therapy. Marital status. Yeah. Okay, good. No, we don't. It's actually not a very good predictor. It's not a very good because these numbers are close to it. You guys following me? All right. So let's get a little bit even deeper. What is the minimum percentage? So this is a question that you may be asking. Maybe you're writing a paper and you want to know this. You want to know this, and this is the paper you dug up. This is the closest paper to answering your question you could find. Can we answer this question? All right. So what's the minimum percentage of mind-body practitioners overall that do some form of relaxation technique and they do yoga or Tai Chi? So yoga or Tai Chi, either of them, and some other relaxation, like meditation, breathing, something like that. So what percentage, what's the minimum? I'm asking that question because it's actually an easier question to answer than what is the actual. Huh? Maybe 1%. Okay, well, how did you come up with that? Yeah. Whoa. Okay. Roughly 3. And how did you? Okay. So I like the way you're thinking. Let me do this for the visual thinkers here with some Venn diagram. How about that? Okay. Let's do some Venn diagram. So this is probably what's going on. This is probably what's going on. The description that you had actually had the yellow circle outside of the red circle, and that's probably actually it's probably some sort of thing where the yellow would be right here, something like that. Okay. That's probably the most likely, more likely. But I'm asking what is the minimum percent. So, all right, here is everybody doing something. Here's everybody doing RT, relaxation. And this is everybody doing yoga. Tai Chi, let's get the minimum percentage. Since it's yoga or Tai Chi, we're just going to make that completely overlap. Since it's one or the other, they're going to completely overlap. And what we need then is this area here. What we want to know is people who do yoga who also do um, mind body therapy. So it's this area in here. So the way that we're going to get that is take this area minus the blue area to get what's in this green area here. All right? And then we're going to take the red area and subtract that from it. So that is 5, which is the red area, minus the difference, 3. And that'll be 2%. Whoa. My point in showing this is that sometimes it takes a little bit of sophisticated massaging of the data to be able to pull out the number that you actually. So this number here, too, is nowhere even remotely in the actual. And if I was asking the question, what is the actual percentage? I couldn't answer that. I couldn't even answer that question. Yeah. The purple, the one in the black. Yeah. Yep, that's 2%. So if you imagine the difference between these, right? Difference between those. So this minus the difference between those is what we're looking at, and that is purple. I don't need you to like actually absorb that number, but the idea that sometimes data has to be like further analyzed over what you have in a paper. This is called meta-analysis, where you can take a study and maybe combine it with another study or survey across multiple studies and reanalyze that data to pull out what you're actually. And also, sometimes this is an important thing to understand that scientific papers can be ambiguous or even misleading without access to the raw data. We probably could answer this. What is the actual percentage of mind-body practitioners overall that do some relaxation and yoga or Tai Chi? But we would have to have the raw data, right? Because the numbers they're reporting are processed. They've been analyzed and processed. And so the actual information is in that raw data, but we would have to have access to that raw data to be able to say that. Some papers, online papers, have raw data in an appendix that's a link somewhere online that you can access. All right. Here's the last thing I'm going to do. I know this is getting Is yoga practice due to income or education? Hard one. He thinks both. Okay, so this requires us to talk about correlation and causation. And things being correlated does not mean that one causes the other. All right, so you guys have all heard this, right? Have you in high school? Maybe no. It's important to understand. So, for example, germs cause bad smells, cause disease, but bad smells don't cause disease. They're correlated, but they don't go hand. Inflation causes the price of the subway to go up. Inflation causes the price of pizza to go up, but the cost of the subway doesn't make pizza price go up. They're just correlated. They're correlated. So there are. Sometimes you want to waste time on the internet. There are plenty of what are called spurious correlations, things that are correlated, but that doesn't mean that they cause one another. For example, the divorce rate here in Maine is not a result of people consuming margarine. How much you consume? I mean, maybe you can imagine some connection, but it's probably flimsy. All right, but they're really highly correlated. I mean, that's an R value, 992,558. My yeah, it's really high correlation. You know, so watch out for the margarine if you want to stay married here in Maine. This is a butter state. Maine is a butter state. Yes, it is. So here, the question then is does higher education cause increased income? Well, that seems like a pretty direct causation. Wouldn't probably. Does higher education cause increased yoga practice? Well, you learn about yoga. You know, I took this cluster when I was in college. I learned all about tissue growth factor beta 1 and the effects of areolar tissue. So I'm going to do yoga. So there may be a causation there. Does this mean this is a correlation or a causation? It gets complicated though, because maybe it's if you can afford to go to yoga class, you do. You can afford insurance that pays for yoga if you've been injured. It gets a little bit question. So does that mean that increased yoga practice is correlated with higher education, knowing something? Or is it all causal? Is it a three-way causal? Yeah, you need more data. You need more data to directly query this question. You need more. Okay, so for the next paper, we're not going to talk about it for a little while, particularly given the speed at which I had seemed to lecture. So this is it, though. This is the paper, and it is not posted on Moodle. What is posted on Moodle, I haven't made it visible yet. I didn't want to freak anybody out before class, but I'll make it visible after classes. There is a assignment portal for the second. And what you're going to do is go into that assignment, and there'll be some instructions. It'll have, in the instructions in Moodle, it has the name of the paper. It has this woman's name here. And it also has the DOI, the date of inception. And you're going to take one of those pieces of information, or both of them, or however, you're going to go to Scopus, and you're going to find this paper, and you're going to download it, and you're going to read it, and fill out the parts of this thing that I ask you to fill out. Again, not the whole thing, but a little bit more than. And then you're going to upload the PDF to Moodle. So I see that you got the PDF, and then we'll talk about it at the end of the next set of PowerPoints. Okay, at the end of the connective tissue PowerPoints, which I don't know how many classes that will be from now, but it'll be over a week. It'll be over a week. I'm guessing probably 2 weeks from now, something like that. Maybe a week and a half. Yes, ma'am. Something like that, yeah. Maybe 3 sessions from now. You can do it tonight if you want. Yeah. This paper is not super intense. And again, please. So as you're reading these, I'm like, oh my God, he gave me another assignment. I'm not asking you to read and memorize this paper. I'm not asking you to spend a long time. You're going to use those techniques that Cara talked about to scan through the paper, get the info you need, and jot it down on this sheet that you'll hand in. The sheet itself, the PDF, is in the same section of Moodle, and you can download it and print it yourself. And then the assignment portal is there where you'll upload the PDF so that I see that you. All right, and we'll talk about that on the far side of connective tissue. All right, so whatever day that is, I don't know because we'll have to see how fast I spent way more time talking about this today. But on to ionomics. Any questions about that? Okay, we're going to start getting more and more sciencey here, folks. More and more sciencey. Boo. It's a science class. It's a science class. You'll thank me someday. You'll thank me. Okay, so I told you ionomics is determining the elemental composition of an organism. So now what we're going to do is, can you guess what makes up a person? It's a game.
Carbon.
All right.
Carbon.
So
Calcium.
let's do it like this.
Sodium.
Hold on. Yes, we're gonna do it like this. We'll have 3 teams. There's going to be the front bench team, Nikki, and the back bench team. Okay.
Great.
The front bench team, the Nikki, and the back bench team. And so, the way that's going to work is, as your team, you're going to huddle together and what elements make up a person without looking ahead at the PowerPoint that I've already posted, because it is like a game. And then we'll see how everybody. All right. So you got wheels. You can move around.
I thought it was yelling out. I was like, no.
Let's see how many you can get. Yeah, put them in order. Put them in order. If you're really feeling tough.
What order?
The highest percentage by mass.
Oh. No.
Yeah. Yeah, and decreasing percentages by mass. Right?
There's a lot of
There's mercury, magnesium, iron.
Oh, I. Sodium, potassium.
We consume made of.
There is the old adage, you are what you eat.
Blood. What is it?
Which is which what?
HF.
HF, hafnium? HF? Really? You're looking for HF? Yeah, that's hafnium. I'll just tell you straight away, there is no HF. You can skip that one. I think hafnium is actually. Yeah, if you need me to tell you what one of the elements' names are, I will.
This is bringing back so many bad memories.
MO is molybdenum. No. No. MO. MO, yeah, molybdenum, right there. Molybdenum. DS. Oh man, you guys are asking weird elements. Where is DS? What number is it? 110. It is super radioactive
No.
at 110. DS is
Einsteinium.
Diostadium? I don't know what that is. I have to say it's elements I've never seen. You definitely do not want it in you, whatever it is. Radioactive. Okay, all right. You guys feeling good with that? Oh.
Barium.
Like I kind of remember like
You need barium.
Is that okay?
Noble gases.
Noble gas.
Yeah.
Right. That's all I remember.
Like not like.
All right. All right. How are we gonna do this? Should we do rock, paper, scissors? See who goes up.
They actually eat barium.
All right.
It's berry flavored barium.
Pick someone in your group to go up there and write 1, 2, 3, 4, 5 down the list of elements that. Pick someone from your group and you say you think that radon is the most common element in a human. You'll just write 1, just like that, right next to it.
Did we do it or not?
The first couple.
And then the,
Oh,
the-
this
it's
marker
free
is
game.
work.
Here you go.
It's free
Here's
game,
your
right?
flash, Nikki.
I agree with that. Okay, well,
Olivia.
Okay, after that, I am
deterred by that.
Is this still?
after that.
I'm gonna just disclose.
calcium. Oh, sodium, potassium.
Wait, did we decide on iron or calcium?
Sodium.
Ooh, sodium potassium pump.
Yes. The action
But what is
potential.
there more sodium?
You talked about action potassium.
In AP Bio.
Oh man,
God.
okay. See, I'm
Oh,
sitting here
yeah.
talking
Like
about
three-
correlation, causation, divorce, and margarine. You guys are potassium, sodium, potassium, ATPase. Definitely require sodium potassium.
Well, you had AP Bio?
Bananas have potassium.
No, I'm allergic.
Okay.
Oh
No,
no.
there's no Which is
All right.
Okay, not for you.
All right.
Oh, it's on.
Well, whatever. You can keep going if you want. Okay.
Phosphorus.
Yeah, go. Actually, number 6. We should go to number 6. Let's go. I'm sorry. I should have
You
said
write
6. What do you want?
Calcium.
Oh wait, so I had sodium is 5.
You could put
Okay,
silicone.
you got calcium is 6. All right.
Calcium is.
All right.
The
All
body
right.
has many nutrients.
All right. All right. So
If you're fake.
somebody took off my red marker.
If you're
Oh,
fake, get silicone.
Miss.
Wow.
All right. 6. Okay.
That's a
let's
lot of
see
6,
here.
bro. It's 3.
It's a lot. Okay, let's see here. But all right. So, the green ones are common. The blue ones are trace elements. And the most common 6 elements are in boxes. So, you mostly got them. Nobody even said hello to nitrogen. No one even said hello to nitrogen. They all thought iron. Why iron?
I didn't.
Because
I
of
didn't. Red didn't.
Blood.
Red didn't think.
Blood
Yeah,
is
it's in your blood.
it's
It's
a liquid
true.
connected tissue.
And then everybody loves sodium and potassium. But they don't even scratch 1%.
Oh really?
Tiny little bit.
Yeah.
A little bit of salt goes a very long way, just like your grandma said.
I didn't know that.
Yeah. You know what? You don't think about it, but you do think about it. You just don't realize you think
Nitrogen
about
cycle.
No. Yeah. Yeah, nitrogen, like, are you, what's one of your favorite meals? Okay, noodles. What's your, what do you have with your noodles, besides just noodles? Okay, all right, come on. Give me somebody with something more interesting than just noodles. Noodles are fine, but you're not helping my story here.
Foie gras.
Foie gras, perfect. Foie gras is unusual but lovely. Made from the liver of a fatted goose or duck. Yeah. Yeah. She's having a hard time with that. But full of protein. Protein is nitrogen.
Oh.
Okay, so here we go. All right. This is a person. 70% of you is made up of water. Everybody knew that, though. All right, 70% of you is made up of water. If you were to, you guys ever had the dehydrated apple chips or something like that?
Oh,
yeah.
Yes.
If you were to do that to yourself, you would weigh only 30% of what you currently weigh. And probably be a lot here, smaller. If you were, you guys were right. Carbon is it is the most common element in the body. Subtracting the water. You're actually mostly oxygen, and that oxygen is in the water. All right. So this is by weight. Hydrogen is actually very light. Well, there's twice as much, but it's a very light element. It's a small light element. Yes, what's up? No. They put that stuff in there so that bacteria won't spoil. It's to prevent bacterial spoilage. Yeah. But we're going to talk about nitrogen in grisly detail, so you just hold on. Yeah. All right, so let's see this in a different thing. These 4 here are 96% of your body weight. So that's oxygen, carbon, hydrogen, and nitrogen. And then there's calcium and phosphorus that make up non-vanishing. So about 1. We're going to talk a little bit about these 6 and the rest of it. We're going to forget about. But why these 4 elements? What is it about carbon, oxygen, hydrogen, and nitrogen that are so important? Yeah, so we're gonna continue to climb the ladder of life. We're climbing the ladder of life here. But I'm not going to presume that everybody remembers anything from chemistry. So I'm going to have just a few slides to refresh your memories about some basic chemistry. Okay, just a few. There's going to be the next lecture here is background science so that we can all be on the same page. Okay? Molecules. All right, so we're taking one step up. We talked about atoms. We're going up to molecules. Here are some molecules. Here is water. Yeah, water. It's made of 1 oxygen, 2 hydrogens that are covalently bonded together. They're sharing electrons. Exactly. Sharing electrons. Yeah. And oxygen has 2 lone pairs of electrons that are not bonding. So it's got some bonding electrons and non-bonding. So this is what's called a covalent molecule. This one here, sodium carbonate, sodium bicarbonate, this is, what else do we know that stuff as? Does anybody know? I'll give you a little clue. Oh yeah, great. Okay, good. Baking soda, Arm & Hammer. Yes, sorry, I wasn't listening. All right. So the sodium, this is the bicarbonate ion. It is negatively charged, means it has more electrons than it normally would, right? If it was neutral, and sodium is missing some electrons. In fact, 1 electron. So it's positive. Because they have equal and opposite charges, they're attracted to one another. We call that an ionic bond. So covalent molecules share electrons. Ionic molecules donate 1 electron to another and then get attracted. So that's, I just want you to be able to see charges. We're going to talk about charges quite a bit. All right. So continuing, here is a little bit more explicit picture of all of this. Here's oxygen with its electrons, and it wants to get 8 electrons in its outer shell for reasons that don't matter to us, right here. And they share electrons and form this covalent bond. Here are those lone pair of electrons that I talked about. Is this all pretty familiar to everybody here? Yeah. No? It's okay. It's all right. That's why I'm going through it, so that everybody is comfortable with these ideas. Covalent bond. It's a bond that's, in general, not easy to break. They're strong bonds due to sharing of electrons. We'll scribble. So I want to talk a little bit about water, because water is super important. It's super important. I showed you that 70% of you is water. So we're going to talk about yoga and how your body works. I need you to understand some stuff about water, all right? And the first thing is that water has a little bit of a dipole moment. This happens, this means that it's a little bit like a magnet. It's not exactly magnetic, like ferromagnetic, but it does have a charge separation that makes it analogous to a magnet. That means one end of the molecule is kind of negative, the other end of the molecule is kind of positive. Okay? The reason for this is that oxygen, the underlying reason, which you don't need to scribble, but I'm going to say it so you hear it, and maybe it will help you, is that oxygen is more what's called, it likes to pull electrons towards it. It likes to be negative. And hydrogen is not very electronegative. It doesn't really. And so this oxygen is kind of greedy with those electrons, and they're sharing the electrons, right?
It's mine.
They're sharing them. And so they're getting pulled closer to the oxygen. So the water is negative on one end, positive on 2 hydrogen. That sets up a really cool dynamic in water. All right? That is what is called a lowercase Greek delta, the lowercase Greek d. So an uppercase one is this. That is why. That's the uppercase. That's a lowercase. So this one, you know, the math term means change in something, right? Like change. And a lowercase delta is similar. It just means tiny little bit of something, a little change, a little increment, a little bit of something, all right? And here it's a little bit of negative charge. And here it's not like a formal negative charge, like a full-on single negative charge. And here it's just a little bit of positive. Follow me? Okay. Yeah, it's less than an electron. It's just a little bit of negative charge. negative density. Because remember, electrons, I didn't want to go into too depth, but electrons are clouds. They're distribution of negative charge. Yeah, we won't go in it. Just yeah. So let's not worry about that. But it's just a little bit negative on this end and a little positive. That's all we really need to understand. And this is great because it helps us put ionic compounds in solution. Here's everybody's favorite table salt. All right. So here's sodium plus the sodium cation plus ion. And here's the chloride anion or negative ion. And for it to go into solution, sodium is going to get surrounded by water molecules that have their negative butts pointed towards the sodium's plus ion. And contrarily, the chloride anion is able to be in solution because it has the positive ends of the water molecule pointed towards it. All right? Yeah, sort of like hands or whatever they are. So positively charged species like sodium ion are called cations. Negatively charged species are called anions. And this is how salt dissolves in water. Yeah, salt water. Not for everybody. Okay, here we go. So let's look at what bulk water looks like. There's one more concept we need. It's hydrogen bond. So in water, in bulk solution, the water molecule is able to form a transient, meaning not long-lasting bond between a hydrogen and an adjacent oxygen in another water molecule. Right? They're kind of sticky because it's a little bit positive here and this one's a little bit negative, so they just kind of form a transient bond, not long-lasting, a little bit of a, and then it'll break and it'll reform somewhere else. It's constantly shifting. These hydrogen bonds, the high capacity for water to form intermolecular between two molecule hydrogen bond, that's what gives water a number of features that make life possible. So, for example, one of them is capillary action. Yeah, surface and capillary action. So water, you know that water beads, right? When water rains, it beads up, even on your skin. And that's the surface tension of the water around the edge, trying to minimize the volume the surface area that volume of water is. That's part of what drives water up into a narrow capillary. So no one's on the other side of that, like sucking on it, pulling it up. It's just the water is crawling up that tube because of capillary action. The underlying feature of water that gives rise to that. Capillary action is important for tissue perfusion. All right, like our peripheral tissue perfusion. Another feature that's really weird about water is that the solid is more. The liquid is more dense than the solid, so the solid floats. That seems like natural to us because we've seen it our whole lives, but it's super weird. It's super weird. Most solids sink if they're immersed in the liquid phase of that compound. All right. So, for example, if you take a chunk of butter and you make a big vat of butter, so like you've seen maybe at like those greasy spoons, they have the big bucket of butter next, like melted butter that sits on the grill, and they like slather butter all over it. And they toast down and pour your eggs and make whatever. That vat of butter, if you stuck a stick of butter in the melted butter, it would go to the bottom. It wouldn't float. All right? Butter. Who doesn't love butter? It's not for everybody. But watch out. Maine is a butter state. Yeah. No margarine.
Or else divorce.
Yeah. All right.
You do that.
Okay. So acids. This is going to be super basic. I'm not going to.
Funny.
Yeah. An acid is a proton donor. Okay, it's just a molecule that wants to give away a proton. A base is a proton acceptor. Those are the definitions that are going to serve us very well in this. An acid or a base. Yep. Yeah, I guess I should have those words typed on here. So let's just do that right now. We'll just do it right now. Acid, proton donor, base, in your face. Proton acceptor. There we go. Yeah. Yeah, man. What did you do in class today? Oh, we just made slides. It's cool. Yeah. All right. And water is able to dissociate into an H plus and an OH minus. All right. In neutral water, there's going to be equal concentrations of H plus and OH minus. However, if you put an acid, some kind of an acid like hydrochloric acid, into water, like would be in your stomach, your body makes hydrochloric acid. The H plus there's going to be more H plus. And so what we know as the pH scale is simply the negative log. It's some math. It's the negative log of the hydrogen ion concentration. Yeah, so you don't need to worry about that. The thing that you need to know is that lower pH means more hydrogen ion, and higher pH means less hydrogen and more hydroxide ion. Okay? Yeah, there we go. Yep. Yeah, low is more hydrogen ion and less hydroxide. And high pH is less hydrogen ion and more hydroxide. It's like I've given you about 3/4 of a semester of chemistry in 20 minutes here. All right. So that is the totality of my review of chemistry for you guys. Yeah, and now we're going to get on to a little bit of biology. So I'll introduce this slide, and then we'll take off with it next time. But so these are the biomolecules of life. We went from small molecules, and we're going to talk about biomolecules, the molecules that make up living cells. There are 4 general categories, major categories of what we call biopolymers, and you'll find out what I mean by polymer in a bit. But those are proteins, carbohydrates, lipids, and nucleic acids. And we're going to stroll through each of those one at a time. Next to each of them, I put the elements that they're made up of. All right, so proteins are made of oxygen, carbon, and hydrogen, but also they're a significant source of nitrogen. And most of the nitrogen that we get in our body comes from proteins and is to make more protein. So the nitrogen that goes in comes from proteins and goes to make new proteins in your body, mostly. However, carbohydrates have the same elements in them, and there is some nitrogen in carbohydrates. We'll see that, like, for example, amine. Lipids. Lipids is a sciencey word for fats and oils. It's a sciencey, yeah. No, we probably won't talk about lipids. Is a sciencey name for fats and oils. And then, of course, nucleic acids, DNA and RNA. And the thing about nucleic acids is this is where our phosphorus. So phosphorus cracked the top 6, didn't it? Yeah, it did. It's because of phosphorus. There's not really any nitrogen in lipids, but the other 3 do have nitrogen. We'll talk about nitrogen. That's all she wrote. Now, I've got 30 seconds. Does anybody have any questions, comments, thoughts? Nope.